Good morning, ladies and gentlemen. My name is Matthias Pfeiffer. I'm heading the technical marketing of the BASF European plasticizer portfolio, and I would like to talk about new plasticizer based on alternative raw materials today. Well, I would really like to be present and stand in front of you, but crazy times in the past changes not only this conference. Well, okay, so a new plasticizer based on alternative raw materials, green, bio, renewable, no new topics, but getting a higher importance. Today I would like to show you how we as BASF will contribute to that, especially to that development within our plasticizer portfolio. Typical drivers for plasticizer development are performance, not only from a technical but also from a cost performance point of view, and also regulatory issues. Sustainability aspects will become more and more important. Criteria that were nice to have in the past are maybe on the way to become a must-have in the future, or even are already a must-have. If you look to the European Plasticizer Portfolio 2020, most of you know that, you will see that we still commit to the C9 and C10 high molecular weight phthalates, palatinol N, the DINP, and palatinol 10P, the DPHP. Some years ago, our phthalate portfolio included 13 different products, so you clearly recognize how performance and especially regulation influence the overall plasticizer portfolio development. We have the hexamodinge, a cyclohexanoate, is our main non-phthalate general purpose plasticizer that targets mainly the sensitive, or let's call it near to consumer application like medical, food contact, toys, or indoor application. To make it short, in all application where customers want to have a non-phthalate plasticizer. And the portfolio consists also on the well-established specialty purpose plasticizer like adipates and polymeric plasticizer, the polyadipates. With this range, we cover most of the applications. There are several other plasticizer families like terephthalates, trimelitates. Both are included in the North American BASF plasticizer portfolio, or other SPP plasticizers like the dibenzerates, sebacates, or flame-retarding phosphates. And there are a lot of different biosystems available, and we constantly get the question, any bio-based or similar development at BASF? And yes, there is a development. If you look to the overall options for biosystems, you either have the opportunities for typical new or not new bio-based structures like fatty acid esters, furanoates, citrates, etc. Or you can choose the same structure as petro-based systems, either from renewable sources directly or, and that is also a way we as BASF decided to go, to use the biomass balance approach to make new products, known products from renewable feedstock. BASF wants to create a chemistry for a sustainable future according to the United Nations Sustainability Goals. This is our purpose, which means we want to increase the role of sustainability in all kinds of business decisions. We have a sustainable carbon management program, and we will go for investments in technologies to speed up circular economy. The biomass balance approach is, among others, one aspect of the BASF circular economy program, where we want to contribute to a more sustainable future. Let's have a closer look to the biomass balance approach, making products from renewable raw materials. Our biomass balance approach contributes to the use of renewable raw materials in our integrated production system, the Verbund system. The benefits are you get the identical products, so no reformulation is needed. Greenhouse gas emissions are reduced and fossil resources are saved, so it drives the use of renewable feedstocks. Such products are easily available, and the concept can be applied to nearly all products in this Verbund system. For the biomass balance approach, renewable raw materials are used as feedstock at the very beginning of the production Verbund and attributed to the respective sales products using a third-party verified certification methods. Renewable feedstocks are used in the very first step, for example in the steam cracker, and the certified approach can be utilized for all production steps and allocated to selected products, and again, these product performance stays identical. Within this approach, an independent certification confirms that BASF has replaced the required quantities of fossil feedstock for the biomass balance we purchase with renewable feedstock according to the Red Cert 2 requirements. In 2018, BASF committed itself to certify all biomass balance products according to the new Red Cert standard for chemical products by the end of 2019. The new systemization is based on the Red Cert European standard, which is compliant with the EU directive on renewable energy. We have decided to start with 4 plasticizers by applying this biomass balance approach. Our new biomass balance grades are hexamaldinch as the non-phthalate general purpose plasticizer for application with close human contact, as I mentioned, the palatinol 10P and the palatinol N, the 2 phthalates as standard general purpose plasticizer for the industrial applications, and the plastimol DOA as a specialty purpose plasticizer with good low temperature performance and also suitable for food contact applications. So 4 new products based on renewable feedstock to save fossil resources and to reduce the carbon footprint, and again with unchanged product properties, so no detailed re-evaluation is necessary. I will also come again later to the issue of the carbon footprint. But before that, to another further pillar in our sustainability approach, ChemCycling, from plastic waste to chemical recycled virgin grade products. This is one further activity within the circular economy program of BASF. Plastic waste is a major global challenge. The society wants to stop that plastic waste is discarded in the environment. Functioning waste management systems and responsible consumer behavior regarding plastics are crucial to solving problems such as pollution from plastic litter. BASF is strongly committed to decrease the amount of plastic waste and to increase the amount of plastic which is collected and afterwards recycled. We are part of the Ellen MacArthur Foundation Circular Economy 100 initiative and implements the Operation Clean Sweep, an international program that strives to prevent plastic loss which may occur during production, transportation, converting and recycling. Furthermore, BASF is a member of the Circular Plastic Alliance and co-founded the Global Alliance to End Plastic Waste in 2019. Moreover, we will contribute to tackling these challenges by developing innovative technologies that promote the recycling of plastic, and a key pillar in this regard is our ChemCycling project. Today's European recycling landscape clearly shows that there is still a lot of room for improvement regarding the recycling of plastics. Even though the overall recovery rate is almost at 72%, only 31% of all plastic waste is recycled, and pretty much all of it is mechanically recycled. Chemical recycling barely plays a role, only 0.1%. 41% is energetically recovered and 24% is still disposed in landfills. Plastics are a valuable resource. We must become a lot better in keeping them in the material cycle. By increasing chemical recycling, more plastic waste will be kept in the material cycle, and at the same time, landfill and incineration will be reduced. To better understand why this will become possible with chemical recycling, let's have a closer look on what precisely happens to plastic waste in the different treatment options. The role of chemical recycling in the circular economy. So for production of plastics, usually fossil raw materials such as naphtha is needed. Naphtha is fed into a steam cracker which produces basic chemicals, mainly ethylene and propylene, and these chemicals are further processed into polymers. And the polymers are then used to produce all kinds of plastic products. Once the use phase of the plastic is over, there are different options. The worst thing that can happen to plastic waste is that it escapes into the environment. If it gets treated, it's either disposed in landfills in Europe around 25%, or it's energetically recovered, again in Europe 42%. This can either happen by incineration and energy use to replace, for example, steam and electricity. Although the plastic waste is reused, the material is diverted from the material cycle and it only has a one-time effect. 2/3 of Europe's plastic materials are not refeed into that value chain. Today, the only broadly existing option to recycle plastic waste is mechanical recycling, but only 31% of the plastic waste in Europe is mechanically recycled, as it is only suitable recycling option for selected applications with a clean single stream and only suitable for thermoplastics. This means that many waste streams, such as mixed plastic waste streams, are simply not suitable for mechanical recycling. And it is also not economical to sort them, so they are incinerated. Furthermore, recycled plastics produced by mechanical recycling generally do not always achieve the same level of quality and purity as requested compared to virgin plastics. So chemical recycling by pyrolysis can increase the overall amount of plastic waste recycled. We are confident that chemical recycling can offer a solution to these challenges and contribute to increase the overall amount of plastic waste recycled. So how does chemical recycling work? In chemical recycling, a pyrolysis process, the polymer chains of the plastics are chemically broken down into small molecules. No single stream waste is needed. Pyrolysis can also handle, for example, mixed and unclean plastic waste that would otherwise most probably be incinerated, like multi-layered food packaging, for example. The resulting product from the pyrolysis is a secondary raw material. This oil can be fed into a chemical process at the beginning in, for example, the steam cracker, so replacing some fossil feedstocks such as naphtha. By using a mass balance approach, the share of recycled materials can then be allocated to certain products manufactured in the production Verbund. Pyrolysis is not the only chemical recycling process. There is also the depolymerization. This recycling technology can be located, let's say, in between mechanical recycling and pyrolysis. In this process, the polymer chains are broken down into their monomers, from which the polymer can be rebuilt. The material obtained from depolymerization re-enters the value chain at a later stage than the oil obtained during the pyrolysis process. However, the process requires single waste streams because it can be disrupted by contaminations. Therefore, depolymerization is similar to mechanical recycling with respect to the sorting requirements. The right recycling option should then be to be selected based on a life cycle analysis. At the end of a life of a plastic product, the most eco-efficient solution should be chosen. Chemical recycling, like other recycling processes, should be also evaluated based on scientific life cycle assessments, and there are cases where chemical recycling is the better options. Within the ChemCycling project, BASF is collaborating closely with its customers and partners, which range from waste management companies to technology providers and packaging producers, in order to build a circular value chain for these kind of plastics. So first, consumers use and dispose plastic products, for example, packaging or tires. Then waste companies collect and sort the waste and supply our recycling partners with it. Followed by the plastic waste is converted into the pyrolysis oil by BASF's partners using a thermochemical process called pyrolysis. This pyrolysis oil is then purified to be used as feedstock in BASF's Verbund production. The recycled or secondary raw material is then fed into BASF's Verbund production. This is all under the mass balance approach. The share of recycled raw material can be allocated to all chemicals produced in these Verbund systems. And finally, customers use our ChemCycling products as usual, as they have the same properties as materials made from the fossil-based raw materials. Again, the ChemCycling project is a complementary approach to existing recycling methods. ChemCycling should not be seen as competition for mechanical recycling. Examples of waste plastics which are difficult to recycle mechanically include plastics with adhering food residues, multi-layer food packaging, or scrap tires or composite plastics used in the motive and construction industries. And also here important to mention, independent institute audit the allocation of the recycled raw material to the end product. After a successful audit, a certificate is issued. In this case, Ecoloop ensures the correct allocation of recycled resources in BASF's value chain. A switch to Red Cert 2 in analog to the biomass balance approach is currently also under evaluation. Currently, we only offer the hexamidinch as the first plasticizer from our portfolio, also in a C-cycled version. Others can follow. Hexamidinch meets the technical requirements for a broad range of products. It has an excellent toxicological profile. It's approved and certified worldwide for many applications. And now you can have that made with chemical recycled material as feedstock that saves fossil resources and thereby increases the plastic waste reduction. Also here, mass balance approach is a third party certified by Ecoloop. So whenever you talk about circular economy, you also need facts and figures. Sustainability indicators in order to prove the positive impact, like the carbon footprint. And you have various stakeholders influencing the overall targets. So how does biomass balance and ChemCycling contribute to the manufacturing of such more sustainable products? Let's have a look to the key trends regarding sustainability. Especially in the plasticizer industry, there is an increased safety and sustainability awareness, and it's not only the general trend towards non-phthalates. Overall, there's a kind of generalization on all kinds of plastic with an increased pressure regarding the reduction of plastic waste. And not to forget the political developments. We have the European Green Deal with the chemical strategy for sustainability. We have the European Commission Action Plan for Circular Economy. There are the United Nations Sustainable Development Goals as part of the 2030 Agenda for Sustainable Development. All these developments can be addressed with our ChemCycling project and our biomass balance approach. Which concept fits best depends on the end product and on the application and how customers want to place their product in the market. Is it more the carbon management or more the aspect of circular economy? In both cases, you save fossil resources and you have the identical product properties, which is very important for the customer. Let's have a look then on the carbon footprint. The biomass balance products reduce the carbon footprint compared to the fossil version. They have around 60% less CO2 emission, some grades even more than 60%. A detailed product carbon footprint and LCA data for these products are partially already available, respectively will be available soon. So whenever you are interested in more data, turn to us directly on the individual products. Chemical recycling is also attractive in terms of CO2 emissions. Pyrolysis of mixed plastic waste emits about 50% less CO2 than incineration of mixed plastic waste. CO2 emissions are saved when manufacturing plastics based on pyrolysis oil instead of naphtha. The lower emissions result mainly from avoiding the incineration of such mixed plastic waste, but also here, detailed data are available on a bilateral basis. All right, so you see, sustainability is an important driver for us with regard to our portfolio development. Based on these both mass balance concepts, we now increased our portfolio by 4 biomass balance and 1 C-cycled product. And further products might come, depends on the overall market interest. So if you have any further questions on that, you find all information bundled on the website. For the biomass balance approach, the ChemCycling project, and also on our plasticizer portfolio in general. You find here the link where you have a lot of detailed information on these concepts and our product portfolio. Or you can turn to us directly, especially if you want to get more detailed information on the LCA, the product carbon footprint, on the certification process, on the overall handling such products, feel free to contact us directly. Or if you have a question right now, I'm open to answer within the next 5 minutes. So thank you very much, and I'm looking forward to answer your first questions.